we're talking about a project we're doing on an S13, which is the 93 240 SX. We had to address some of the inherent chassis design flaws that Nissan gave us, along with repair existing damage. The particular car is a drift car, so some of the stuff we needed to address was lack of steering angle, lack of chassis rigidity, and just overall lack of room for the engine swap that the customer is asking for. So the first part of this project is to verify the chassis is square. So to do that, we put it on the frame jig and measure all the pickup points and all the chassis points and make sure it is a usable chassis. Once that's completed, we move on to the next step, which is bracing the chassis so that we can actually start cutting it. A lot of shops will just immediately start cutting these cars apart. That's a very dangerous thing to do because you'll never retain the original chassis in the way it was designed to function. So when we talk about bracing the chassis before doing any modifications, what we're actually doing is creating a steel inner structure that goes from your main chassis pickup points. So we're talking about your struts, your firewall, your engine mounts, and your front frame horns. That's what's critical. And what we do is we create a triangulated system for containing all these components so they're not moving around when we remove material and also when we add material. So once the inner structure is all braced and it's all ready to go, what we do is we clean up all the seams, which when we say seam, we're talking about where the pieces of sheet metal meet. Modern cars are obviously a unibody design, so there's no true frame. So what we're given to work with is sheet metal that is spot welded. So in order to make this more rigid, we actually go through and actually seam weld all the seams where the sheet metal meets. And you can see there's a lot of them and it's very time consuming, but it makes a massive difference in your finished product and the rigidity. So a lot of the design cues on this particular tub job come from the fact that we know that he's increasing the power by a good margin, and we know how flexible these chassis are when they are stock. So what we did is we tied in from the strength of the upper shock tower, or your strut tower, and tied it directly into the frame rail. Anytime you'll see a lot of S13s and S14 chassis where they have tubes coming down and over and snaking around, and basically the more bins you put in it, not only the more material adding, so the more weight, but you're also creating a bunch of internal bending moments in the tubing, which translate into flexibility. I mean, as soon as you have more than 2 S-bins, you have a bunch of flex in the chassis now. And so what we did was we minimized the number of bins. We gave them the minimum number we had to clear the wheel tubs, but also we completely did away with any S-bins. So one of the interesting things about this project is the large Dimple die gussets that run transverse to the wheel tubs. A lot of people think it's just for style, but we effectively did was created, rather than sheet metal here, it's actually now what you could effectively call the thickness of this metal with the Dimple dies. So we're adding a ton of rigidity to the front nose without adding a ton of material, and that's the reason we use Dimple dies. But that's also why we run the material transverse, because obviously if you put a board like this, it's very hard to bend it, but if it's like this, it's super flexible. One of the biggest challenges on this front end that we ran into was the pop-up headlights that you see here. What you see above the car is just like a small opening in a headlight, which you have to remember is all that has to be able to fold down into the front end, making it very difficult to not only mount them where they line up with the hood and bumper properly, but also leave enough space underneath for them to fold in when they're not in use. In order to do this, we actually had to get creative with our mounting procedure, and the mounts hang off of the structure in order to give the headlight plenty of room. They basically are floating with nothing underneath them, nothing to encompass them. So now you can see the inner structure with the bumper removed, and you can see what we did here. A major thing with the rigidity that we added with the Dimple dies, the wheel tubs, and the tubular nose here is that we don't actually need a core support or any front end. There's no cross member here, and what that gives us space for is a larger intercooler, a larger radiator, a V-mount intercooler. It gives us lots of options as far as what engine he's running with what peripheral items that go on the front. What you can also see is that there's plenty of room for the headlights, and that these crash bars actually protect the headlights in the event of minor damage. Now, one thing that we did design with this front end, because these cars are known for pushing it to the edge, the front nose piece is actually removable, and it's actually built onto shear points. So in the event of a wreck, you're not going to hurt the actual frame, you just tear this front piece off, and it becomes basically like a modern car that has a crumple zone. This is your crumple zone. Even if it's a lateral hit, you're just going to rip off the tubes, and you're not going to hurt all the hard work that we have in here, which would be the engine, the tranny, all the intercooler, all that stuff is protected. So the reason we did this video is to kind of show you the in-depth insight to what is the method behind our madness, why we do certain things, why what we do is completely functional rather than ornamental. We really focus on the details, and we focus on the fact that if you're building cars like this, you're going to be working on cars like this, and bad stuff's going to happen. So we put a lot more development into the maintenance, like we talked about the shear points, stuff being able to be removed, stuff being able to be rebuilt. And a lot of stuff you see here also is all kept in our records. It's all engineered and designed, so we can replicate it easily if you ever do have issues with your car getting damaged or lost or stolen. So I hope you've enjoyed this video. I hope you've learned something. I hope it's been informative. Some of the reasons we do stuff like this is the reason we also have like a Facebook, which is facebook.com/Rhom Innovations, our website, rhominnovations.com. We're also on Twitter. A lot of this is just to show what we do differently, and also just full disclosure with our clientele. We do a lot of stuff that no one else does, so we have to have full disclosure so you know what you're paying for and what you're getting. And so yeah, check us out on the web, and until next time, I don't know.